Assalamu alaikum wa rahmatullahi wa barakatuh. We are Group 7 from Section 3, Communication Principle from University of Technology, Malaysia. Today we will discuss about Introduction to Pulse Position Modulation, which is known as PPM. But first, before we are starting, scan the QR code or the link in the description so you can give us your feedback later. For our group member, we have Abu Bakr Nazar Osman and Fairuz Alicia and Noor Husna and me, Muhammad Al Ayah Yusuf. So what we will discover today. By today, we will learn about modern communication system and how message travel invisibly through the air, and learn also a clever way to encode information using time, and also learn how why the position is very matters more than you think. And at last, we will show some real world application me and you use every day. So modern communication systems are designed to efficiently transmit information over distance. At their core, they consist of three main stages. The first stage is the sending, which is done by transmitter, and in this stage, where the information is prepared for transmission. And at the second stage, we have processing, which is done by the channel. This is the medium through which the information travels. And last stage is receiving, which is done by receiver. This is where the original information is recovered. In these systems, information travel in the form of signals. Audio, images, and data in general are first converted into electrical signal at the source. These electrical signals are then fed to antennas or the other transducers to be sent out as electromagnetic wave through the air, wireless, or along medium like fiber optic cable wire. So before we reach modulation, we must understand the essential characteristic of any angle, any signal. Think signal as a wave. First properties, we have amplitude. Amplitude describes the height of the wave, similar to the difference between a shout and the whisper. Second, we have frequency. Frequency is the number of cycles per second. High frequency means the signal will vibrate more rapidly, while the low frequency move more slowly. Last, we have the phase. Phase indicates where the wave begins in its cycle. Much like two jump rope motion that start at different moments, they will be out of phase. Each of these properties can change independently. Keep these three in mind, they form foundation of all communication techniques. So what is a modulation? Modulation is a process of carrying carrier signals probabilities to encode information. We have three key components to understand more about modulation. The first key component is the message signal. The message signal is the original information, voice, data, music, and so on. And second, we have carrier signal, a high frequency wave that carries the message signal. At last, we have modulated signal, which is a combination that is ready for transmission. So why we need the modulation? To enable long distance transmission and to reduce interference and allow multiple signals to share the same space. If you want to explain more about modulation, we can use simple example as like you have information as a letter and the carrier wave as the envelope built to travel a long distance. Modulation is the act of placing your message onto this carrier wave so it can move through space reliably. Once modulated, the carrier transports the information efficiently while the communication system ensures it arrives intact. So for the type of modulation, there is a lot of type for modulation. But for example, you have two types, which is AM amplitude modulation and also FM, which is frequency modulation. So this is a message signal and carrier signal, and in AM amplitude modulation, we basically change the amplitude of the message signal, and for the FM, we change the frequency of this message signal.
After you have understood basic signal properties and you have understood what modulation is, you are ready for our topic of the day. Just now you have seen AM and FM, which work on analog signals or continuous waves. The next step is we will study modulation techniques that work on digital signals. Digital signals are kind of like pulses. They can either be on or off. To encode them, there are many special ways, such as PWM, pulse width modulation, or our topic for the day, PPM, pulse position modulation. Before we dive into pulse position modulation, we first must know how PWM is generated because PPM is derived from PWM. So we take our analog signal and we take snapshots of its amplitude at regular intervals. This is called sampling. The next step is quantization, which is just a fancy word for rounding. Imagine you are rounding the prices to the closest dollar. We use this data to generate pulses. The pulse width depends on the amplitude of the signal at this given time. So now it encodes the amplitude information. Now to explain PPM, imagine you have a bell. Each time you ring it, it indicates that dinner is ready. Another way you can use the same bell is by ringing it at different times. So at 6 o'clock, 6:15, and 6:30, each time you ring the bell at one of those times, it indicates a different bell. So the bell itself hasn't changed, but the way you used it gives a different meaning each time. This is exactly how PPM works. The time slot structure of PPM is that each signal or each pulse is given an equal slot of time. When the pulse appears, it determines the amplitude of the signal at that time. So for a lower amplitude, the pulse appears earlier in the slot, and for a higher amplitude, the pulse appears later. Now let's see how our pulse position modulation signal is generated from our input analog signal. We will first sample the analog signal, and based on the amplitude, we will get our pulse, either later in the slot or earlier in the slot. The higher the amplitude, the later the pulse appears, which makes it immune to noise. As long as you can detect the pulse, you can know the original amplitude. Let's drive this home with more examples. First, we will take a low frequency sine wave, and then we will take another low frequency sine wave, and then you can see another square wave, and finally we have a complex multiple frequency wave. Each one gives a unique pulse pattern. Now we will see how PPM is extracted from our PWM. We will take our analog signal, we will sample it at different intervals. This will generate our PWM signal. This enters a circuit called a differentiator. It detects the falling edge of the PWM signal because all PWM signals start at the same time. So when we detect the falling edge of the PWM signal, we can know where to put our pulse. And that's exactly what the differentiator does. It generates a pulse for each time it detects a falling edge of the PWM signal. This gives us our PPM signal.
So for PBM generation circuit, we don't need to dive on much detail for circuit components since our audience don't have engineering background, but you need to know one thing that the PWM pulse enter monostable multivibrator, and that's how we create the PPM signal. So for the conversion process, the PWM pulse goes into a differentiator, and then sharp spikes appear at pulse edges, and right in those rising edges spike trigger BBM pulse, which is result the pulse position event the signal value.
Now let's look at how PPM can be demodulated back to the original analog waveform. We will start with the general block diagram. It starts with a power splitter that splits the signal into two identical passes. One goes to the ramp generator, another one to the pulse generator. Those two are summed together. The clipper tips the amplitude, and the low-pass filter smoothes out unwanted frequencies. Let's take a look step by step. In pulse position modulation, the information of the amplitude is coded in the pulse position. The threshold detector identifies when each pulse appears and timestamps its location. Next is time is converted to amplitude through a specific equation. Each time the pulse appears is mapped to a certain amplitude. Then the low-pass filter smoothes out all unwanted frequencies and it gives us our reconstructed signal.
And for the pros and cons, the advantage of BBM is one of the advantages is noise immunity, only timing matters, not the amplitude. And also power efficiency, short pulses equal less energy consumption, and also high accuracy and simple detection. But also we have some disadvantage, which is synchronization required. Receiver must know timing preference, and bandwidth used require more bandwidth than the analog. And also we have complex circuitry, more components than a simple AM and also FM. Plus, we have some examples from real-world application of PPM. Where do we use PPM? We use PPM normally in fiber optic communication, in high-speed internet backbones, and long-distance telephone network, and so on.
Now let's look at the most recent advancement in PPM demodulation, the application of deep learning algorithms. Traditionally, demodulation relies on several stages that require precise synchronization and they are highly sensitive to jitter and cannot fail. The deep learning method, the neural network, learns the entire mapping directly from raw PPM pulses and maps them to analog values. As you can see here, we feed an actual PPM waveform into the network. It flows through each layer and extracts high-level features, refined timing information, and interprets the pulse structure more accurately than classical methods. This demonstrates how modern communication networks can outperform traditional signal processing methods and opens the door to robust PPM demodulation in real-world communication systems.
And also we use it in aerospace and satellite system and in remote control system and also in medical field. Hope you learned something new today and don't forget to fill out the feedback form by scanning the QR code or through the link in the description. Fill your details and select groups number 7. And that's it. Assalamu alaikum wa rahmatullahi wa barakatuh.